Welcome to a lesson with Dr. Powell. Let's take a look at an application of the mean value theorem to runners in a race. Suppose we have runner 1 and runner 2. And this graph represents distance. Now they're running just along a straight track, but we're kind of measuring their distance with regards to time, so we can kind of unfold it in this way. So runner 1 seems to be going faster at first because the slope of this line is actually speed. Seems to now be slower than runner 2. The question at a particular moment when they're observed from at different positions with runner 2 ahead, the question is there ever a moment in time when both runners were running at the exact same speed? Now, if you take a look at the function f minus g, f minus g is kind of like, in some sense, like taking the g line or the g curve and kind of wrapping and folding it down to the 0 position. So kind of just looking at distances between things. And then you're kind of doing it vertically here. And if you did that, your graph wouldn't really exactly look like this, but roughly get this general idea. It does something like this. Now, notice that on this interval from here to here, using the mean value theorem, there's a point somewhere in the middle at point C, perhaps at a time C, such that the derivative of f minus g is going to be equal to 0 because that's the secant line here, the slope of the secant line. But what does that mean? Now, derivatives distribute nicely over subtraction. So this is like saying f prime minus f prime evaluated at c minus g prime evaluated at c is equal to 0. Or in other words, it's like saying there's a moment in time where their speeds are the same, just as desired. Thanks for watching.